Here's what nobody tells you when you become the manager of an AI team. The skills you learned managing a software team will mislead you, not because they're wrong, but because AI teams fail differently, estimate differently, and succeed differently. Let me tell you what actually works.
For decades, software engineering operated on a logic of strict causality. You write the rule, the computer executes it. It is a world of deterministic code, where inputs produce predictable, repeatable outputs. Because the code was predictable, the business built around it could be as well. Traditional management styles, marketing roadmaps, and corporate targets were all constructed on the assumption that a competent engineering team could provide a specific delivery date for a specific feature. This shift from a solid line to a probabilistic scatterplot represents the transition to modern AI development. We are no longer programming explicit rules, we are guiding models that learn from millions of external examples. The system's behavior is now governed by weights, thresholds, and statistical likelihoods. In this environment, no inputs are truly independent. If the distribution of a single variable shifts, every other feature in the model recalculates its importance. This is the CACE principle. Changing anything changes everything. This Google research diagram illustrates why that instability matters. On the left is the simple pipeline of traditional software. On the right are the complexities unique to machine learning, data dependencies, feature extraction, and constant monitoring. When leaders try to force the system on the right into the management timeline of the left, projects stall in the prototype to production gap. Leading an AI team requires moving past the illusion that the work is linear. The goal isn't to make the development predictable, but to build an operational system where unpredictability is manageable. If the code is no longer deterministic, the management cannot be either. This forces a shift in how we define engineering leadership, moving from managing code to managing the system that produces it. When an AI team misses a deadline, it is rarely due to poor estimation. It is a reality of the work. Training a model is an experiment with a binary outcome. It either achieves the required performance or it doesn't. You cannot accurately estimate the completion date of a discovery. Managers solve this by using confidence intervals. The commitment to stakeholders shifts from a specific launch date to a specific date for learning. You are promising the date on which you'll know if an approach is viable. This experimental reality creates a structural tension. Researchers optimize for exploration and novelty, while engineers optimize for reliability and scale. Forcing these two functions to share a single sprint timeline leads to systemic gridlock. You resolve this tension through swim lanes. A cyclical loop for time-boxed research runs parallel to a linear pipeline for production. A model only crosses into engineering when it meets explicit criteria: verified benchmarks, a reliable data pipeline, and a clear rollback plan. Separating these tracks isolates the volatility of research from the reliability demands of production, ensuring a failed experiment doesn't derail the roadmap. Because the daily work involves high failure rates, psychological safety serves as a technical guardrail for the team. Research from MIT suggests that when people face the potential for embarrassment, they act in ways that inhibit learning. In AI development, where models frequently fail to converge or data proves flawed, silence is a risk factor for the entire system. If an engineer feels the need to hide a failed experiment to appear competent, that error remains in the codebase. In a system as entangled as a machine learning model, these hidden failures make long-term stability impossible. Managers can neutralize this threat by making failure a data point rather than a personal judgment. A weekly ritual of asking, "What failed this week?" turns a botched experiment into actionable information for the rest of the team. This culture of open inquiry also changes how you hire. When the underlying technology evolves every few months, a prestigious degree is less valuable than the ability to master a new framework in a single weekend. You find this adaptability by having candidates explain a newly learned concept to a non-expert. This doesn't just test their knowledge, it reveals their learning velocity and their ability to distill complexity into something legible. Optimizing for this curiosity ensures the team can pivot as fast as the technology itself. A safe team that asks better questions will eventually outperform a prestigious team that is afraid to be wrong. Even with a resilient team, you face an external friction point: running an ambiguous AI project that must mesh with a business requiring absolute certainty. The most common management mistake is protective hiding. This is when a leader shields stakeholders from uncertainty, hoping to resolve experimental issues before anyone notices. It works until it doesn't, resulting in catastrophic late-stage surprises. Proactive transparency is a more sustainable path. Using a weekly reporting framework, you outline what the team knows, what remains unknown, and which specific variables would force a change in direction. This consistency builds a trust budget. When you are transparent about the risks early on, you earn the political capital required to rescope a project or delay a launch when the data requires it. This is the distinction between a tech lead and an engineering manager. A tech lead executes the technical work. An engineering manager builds the organizational system that protects that work and translates its risks to the wider company. Ultimately, success in AI leadership isn't measured by how well you avoid ambiguity. It is measured by your ability to design a system that can consistently ship products in an environment where the outcome is never guaranteed.
Leading AI teams is about more than just the tech. It's about building the conditions for the smartest people in the room to succeed. If you found this signal useful, hit like and subscribe